are kicking off the show right away. We're kicking off the show with Fresno State's Physics Outreach. So our favorite physics professor, Don Williams, he joins us along now with one of his students. This is UV, and we always love having you guys back in the studio, lighting things on fire, breaking things. Anything new happening with Fresno State Physics Outreach? What's going on with you guys?
Well, we got a new group this semester, as you can imagine, Emily, and this is one of them, and we're just doing an awesome job. We've been to a lot of places already, and we're going out to a special one coming up. We're going out to the Veterans Home.
Oh, that's great.
Yes, won't that be pretty cool?
I think that's a great example of the places that you go, because we always talk about elementary schools and little kids and stuff, but you know, you're never too old to learn something new.
Oh, and we have a lot of fun.
And we're learning today. What are we learning about?
Well, I'm gonna let UV take it over here. I know she's got a torch. You go ahead and tell
UV, you're gonna light some stuff on fire.
What are you gonna do?
What are you teaching me today?
Okay, so I'm going to tell you the difference between these two pennies. So odds are the penny here is, you can see it's super dark, and this penny, odds are it is actually older than like 19, what do we say?
85. Used to be, that don't seem that old, right?
It's older than me.
So copper itself will not melt no matter how much heat is distributed to it. So I'm actually going to show that to you right now. I'm going to try to set this guy on fire, and you will see that it will not melt.
We're going to try to melt it.
Right.
Yeah.
So that torch is like 1,500 degrees, but copper won't melt at that.
Oh my God.
It looks like it, but it won't.
Are we cleaning this penny?
No, it's
not. Or
not.
is it just light? Is it just turning red?
Heating it up. It's just heating it up, but it will not melt. That's what we're telling you.
Okay, so pennies before 1985 made of copper.
Yep,
pure
copper.
Cannot melt copper.
With that torch, exactly.
That's
you get a
why-
hot enough wood,
That's why everybody wants to get their hands on it. All right, what do we have here?
So here we actually have another newer penny, and I actually want you to melt it. And it actually
Me?
Yes.
Yeah.
You actually
now
have
be careful when you put it on the tongs there. It's still hot a little
This
bit.
is our entire budget right here.
There you go,
I'm
right
gonna
there.
melt it.
Thanks, Rick.
Okay, that's my penny.
There you go. Now hold it over that. Let's see if you can melt it. Get it pretty close there. Keep it on there really good, moving it around. And what we're going to tell you is
my
that,
my heart's breaking a little bit.
There it goes. Look, it goes, Emily. There it goes. Keep it up so the camera can see it.
Oh my goodness.
Look at that.
That was my entire paycheck.
That's
no,
it.
I'm kidding. Oh my
So
goodness.
that's the copper left, and then the zinc dropped out in there. Just melted out of there.
And so zinc melts
At a lot lower temperature.
at a lot lower temperature.
If that
Could
can
we
melt it.
ever melt copper?
Oh, yeah. Absolutely.
This just isn't.
That's it, powerful
We didn't bring the big guns to the studio today.
Exactly.
Okay, lesson number 2. What are we learning about?
Okay, now we wanted you to feel these two things here. We got an aluminum tray and a wood tray. People are familiar with that, like a wooden spoon and a. Which one felt warmer?
The wood feels warmer.
It feels warmer. Now, if I put a piece of ice in there, what do you think is going to happen if I put a piece of ice in there? And both of those, is it going to melt the same
Well, your mom's going to
speed?
get mad at you because you don't have a coaster down on the wood.
Okay.
But it's going to melt in this one faster.
Faster, okay. Even though you said it was warmer? Okay, let's put it in the wood. Okay, it's not doing much there.
No.
Let's put one in the metal.
Oh, that one's,
Is it
look
already
at it.
It's already starting to melt,
The
just like you
Wicked Witch
said.
of the West.
Look at that.
I knew that
Look at the
because
wood.
we've done this one
Right,
before.
because now what's the reason, Emily? Why is it melting faster in the metal? Thermal conductivity, huh?
Okay, I knew it was something about but I couldn't think of the word. That it sucks out more. You know what I mean?
Think of it faster.
But conductivity. That's the word that we're trying to think of.
And see, look at that. It's almost all gone.
Yeah, it is.
Look at that. Almost all gone. So again, when you guys actually thaw your food at home, put it in a metal pan.
Oh.
See, because remember, that's at room temperature, even though it felt cold, and you see how fast it happens, right?
What is this exact metal?
That's just aluminum.
Oh, aluminum.
That's all that is aluminum. But really, any metal, really things that are good thermal.
Conductors of thermal energy?
Right, are usually good electrical conductors. So things that kind of go hand in hand.
Okay.
All right.
All right,
Now
next
we're going to do something a little different. Now.
All right.
Okay, so this is a little different. We'll move this over here. So this one here, we've got the classic big truck and the little truck.
Yes.
And we're going to crash them.
Okay.
Right? So we're going to crash them into each other. Boom! All right? Now here's my question. Did they both experience the same force? Or did this have a bigger force or this have a less force?
Okay, so you might think that this one experienced more force, but the force is not what happens afterwards. The force was you forcing them together.
Okay.
Same force.
You're on the right track.
Right?
You're on the right track. So when they made the collision, even though I wasn't touching them, that force was the same.
Okay, now what if a really strong person does this one and a really weak person does this one?
Then you would have more energy, right?
More
then you would
energy,
have
but the same
But guess
force.
what? The force would still be the same.
Oh, okay.
You might not get knocked out as much.
Yeah.
But the force would be the same.
Okay.
What happens is it's the acceleration is what we're actually
what we
visualizing.
see.
That's what we
Okay.
see is the thing moving around,
Yeah.
right? That's the acceleration. The force happens the minute they come
They
in contact.
touch. Oh, okay.
Boom.
Got it.
Exactly.
Okay, this next one, I
Now,
like this last
one, you got it. Now, this one here we showed you is we had 4 different size spheres, right? A
Yes.
ball on the bottom and so forth. Now, I showed you how to do that. You're going to pick that up a little
Okay.
bit and let it fall and watch what happens. Look how high
I love it.
that one went right there. So what was happening, the way the size of these are, all that energy was being transferred to that. So as it dropped, it had momentum. Then it made a collision.
Energy.
Right, exactly. It had energy.
And then it goes-
And it goes up to that right there. It transfers
Because
up there.
what's the saying? Energy is never.
Never
it's
created
it
or
just
destroyed.
Right, it just transfers.
Exactly, just
Got
goes from one form to
it.
another. See, look at all the stuff
I
you
know, look
learned.
at all the
You
things
in
that we're
physics, man.
learning.
She's
And
learned tons of stuff.
you guys out there at home, our veterans,
Exactly.
our elementary school kids, you guys could all learn this too. Fresno State Physics Outreach, they can come visit you with all of these experiments. And you guys are going to stick around.
Absolutely.
And we're going to see and do more in just a little bit. Stay right there because we've got more Central Valley Today. The Sequoia Symphony Orchestra, they've got a performance coming up. We'll tell you all about it.